right into it. We're going to be dealing with matrices for a minute. Today's lesson, I feel like there was a class I had to take in college called linear algebra, and this was the stuff that was so hard for me. Now here's the thing, guys, I feel like I didn't have the correct guidance to make it not that hard. I feel like if you guys follow my step-by-step instructions, it won't be that bad. So just everybody focus, please, and then just take my advice. If I tell you to do it a certain way, do it that way. All right, awesome. So we already know how to solve a system of linear equations. So if I gave you this system right here and said solve, you'd say, okay, I can solve by elimination or substitution. So you would say, I'm going to eliminate x. You would times this by -2, add straight down, right, everybody? So we do know how to already solve. Now here's the thing, what we're doing today is we're just learning an additional way to go about solving a system of equations. Now it might take a little longer, and it might feel like I would rather do a different way, but we have no choice but to solve it this way. It is the process that we have to learn. So first, before we can learn this new way of solving a system of equations, we need to know a little bit about how a matrix works and looks. So right here is the matrix form of this system of equations. So notice, where are these numbers coming from? Well, yeah, they're the equations, they're the coefficients. See, look, 2, -1, 5, 2, -1, 5, 1, 4, 7, 1, 4, 7. So just notice, like, if we can switch back and forth, so it would make sense that the first thing will be an x, y, and then this final thing will always be the equals to, right? The constant, in other words. Now, also, a couple little things about matrix that are important for later lessons is how we would say, like, how big this matrix is, or the dimensions of this matrix. So we always state it as row by column. So we would say this has 2 rows and then 3 columns. So this is considered a 2 by 3 matrix. 2 rows, 3 columns.
We learned this in 6th grade.
Probably. Yeah, you probably did do some basics.
Yeah.
Yeah, you guys probably did do some basics with this, yes. So then also, these are different elements, like 2 is an element, -1's an element, 5 is an element. Basically, I'm asking you, where does this sit? Where does 2 sit within our matrix? So notice, 2 sits within the first row and first column. So this is how I would denote it, A sub 1, 1. That means first row, first column. So right here, number 7 sits in the second row, third column. Once again, we always do row then column. So notice, look, second row, third column. So if I said to you, what's A sub 1, 3, you would say first row, third column is 5. Okay, good. So those are just some little things about a matrix. Not super important for what we're doing today, actually, but it's good to know. You don't need to write this down. Just watch. Just watch this, really. This is not important for today. I'm just making sure we know the basics for a matrix. Here's the matrix form. It's called an augmented matrix. Here's the augmented matrix of a system of equations. So if I asked you, what's the system of equations? You would say 1x plus 3y equals 0, yeah? And then say 2x plus 4y equals -1. Check. All right, now this is a what size of matrix? A what by what? 2 by 3. Okay, good. What entry is 0? A sub what?
A sub 1, 3.
1, 3. Okay, good. First row, third column. And then what is A sub 2, 1? 2. Awesome. So those are just the little basics of a matrix. And now we will get to how we're going to actually use this. So another just formality we have to cover, is just talking about if you're missing something, make sure you put in a 0. So obviously right here, see how there's 0? We would write this as, right here. 3, -2, 1, 5, 1, 3, -1, 0. So then right here is, -1. Then there's a 0, a 4, and 11. So right here I've done this really messy. I would really try to line things up prettier when you actually do it, okay? All right. Just make sure you put in your zeros. Okay, write this down right here. So this is what's called row echelon form. Write that down. Row echelon form. So row echelon form, we're not learning right now, not at this exact second, how to get to row echelon form. I'm explaining first what row echelon form is and what it looks like, basically. So here's a matrix that has been, we've done some math on this matrix, pretend, and we've got to this form. So what row echelon form is it has a, look, see how this says 1x right here? And then there's a 0x plus 1y. Then there's 0x plus 0y plus 1z. So basically, look, there's 1's on the diagonal and 0's below. That's what row echelon form is. Only 1's on the diagonal and 0's below. If you get a matrix using algebra to this form, if you get it to this row echelon form, you actually can solve. Because look, what you would have is a true statement. You could put it back into its equation form. Look, right here we have 1z equals 5, don't we? So if z equals 5, great. We've just found what z is. Now look right here. Now we would have the true statement y plus 2z equals negative 1. And because of that, look what we can do now. We can plug in 5 right here and solve for y. So that would be 2 times 5 is 10. And then you'd subtract 10, so wouldn't y be negative 11? And then look, we could then solve for x, because look at our top true statement. 1x plus 2y minus 5z equals 3. So then we would just go and back substitute that in here and that in here. And then we have found our x, y, z as our answer. Does that make sense, everyone?
It's basically like a shortcut, quote unquote. So
Yeah.
it's something you have to notice when you are doing the matrix. Like it's one of the
We're gonna purposely get it to this form. Yeah. So we're gonna use math on purpose to get it to this form, so then we're able to solve it.
That's cool.
Yeah. All right, good question. And then, so reduced row echelon form, notice instead of just row echelon form, now we're in reduced row echelon form. Notice what happens is there's ones on the diagonal, zeros below, but also zeros above our ones. Now, if you can get a matrix into reduced row echelon form, you don't have to do any back substitution because you've already solved. Look at your true statement. X equals 2. Y equals 3.
Oh, wow.
Z equals negative 5. So if you can get a matrix to reduced row echelon form, you're done. You've solved it. Now here's the thing. We have to do math to get our matrix to this form and this form. So to me, if I'm given the choice to do row echelon form or reduced row echelon form, I actually usually just stop at row echelon form because you're going to see that the process to get here is just kind of tedious. So I usually just get to this form and I'm like, I'm good. I'll substitute. Yeah. But that's just me. A lot of people do like reduced row echelon form because then there's your answers. All right. Now it is just, it's going to feel a little weird at first solving these. Okay, here are the steps we're going to take. Now that you understand what row echelon form is and reduced row echelon form, here are the steps we're going to take to solve. So this is called, in your notes, I'd write solving by Gauss elimination. So we're solving a system of linear equations with Gauss elimination. So Gauss is the mathematician that realized that you can take a system of equations, write it in its matrix form with its coefficients, and then put it into row echelon form, and then that'll allow you to be able to solve it. So that's why he's given the name, Gauss elimination. Yeah, I know. Okay, so first, write the system of equation in its matrix form. So don't write this down. You only need to write down step number 1. Write the system in its matrix form. So I'm just showing you an example. Here's my system, and I put it in its matrix form. Now second, you then use row operations to get the matrix to row echelon form. We're going to have to do the math, and we're going to get it to row echelon form, not reduced row echelon form. That's a different type of elimination, it's just the same thing, just going even further. So with Gauss, he only got it to row echelon form, which means 1's on the diagonal and 0's below the 1's. Now here's the thing, once we get it to, I'll just go to step 3, then I'll go back to step 2. Once we get it into row echelon form, we just saw a second ago how we can then use back substitution to solve for x, y, z. Now here is the important thing to note, okay? This is really, really important to understand, you guys. We are going to take this matrix and we're going to get it to this format. To get this to this format, we can only do the following things. Row operations only include these things. You can take a row and you can times it by a constant if you want. So if I wanted to take this top row and times it by 2, I could. Can I add 2? No, you can only times by 2. You can only times by a constant, okay? No adding a number. Now you can add 2 rows together. So if you wanted, you could choose, we're going to choose strategically how, in a second you'll see, but let's say I wanted to add row 1 and row 2 together. I could if I so wanted to. Now also you can just switch rows randomly. Like I could literally take and make this my top row if I so desired, or I could switch this row with this row. It doesn't matter. If you do any of those things, it will not change the solution, but you can't do any other type of operation. Now here is the next really important thing. I used to go about this randomly, and that's why it was really hard for me. I remember back in college, I would go about it randomly, and right there is why I had a hard time. So everybody listen to the steps you're going to take. Just trust me, okay? So So what you're going to do is first, you're going to start with getting your 1 for x. Then you're going to get zeros below the 1. The next step is to get a 1 for y, then get zeros below. Then get your 1. So basically you get 1, then your zeros. Get 1, then your zeros. Does that make sense? Get your 1. So we work down. 1, zeros, 1, zeros, 1. And if you go in that order, it's just going to be way more likely that you are not all messed up and all over the place. Also, guys, once you get your 1 and your 0, 0, you're not going to want to choose to do anything that would then change these back to not 1 and 0, 0. So you'll see what I mean by actual practice. It's kind of hard to explain without just showing you. All right, can I go to the next slide, or do you need more time on this slide? Right. Yeah, so once we get the 1s on the diagonal, 0s below, well, basically, then we have our true statement, because we don't have 0s above, so we haven't solved it. Does that make sense? So then we'll actually have to go through and solve. Okay, now the key here, you guys, is just like showing your work, and I'll just show you how I show my work, and then I'll give you some suggestions on how I think is going to help you not make errors. Take them. Usually when I suggest something, it's because I have had trial and error. Like, I sat down over spring break and practiced all of these, and this is what I was finding most efficient. Yeah, thanks. Okay, so this is solve using Gauss elimination. So our first step, I would write this down. This is our first example. Our first step is to write it in its matrix form. Keeping things really pretty and in line. So what I mean is like the 3 directly under the 4, 8, 5, -11, -2, and 12, -17. Make sure you guys ask questions if you get confused or are stuck or anything. Okay, so remember the next step is to get it so there's 1s on the diagonal and 0s below. Now remember, if you need to go in this order. What you need to do is you need to have in this first position here, you need there to be a 1. Now, anytime I'm trying to get a 1, I usually just times by something that will make that 1. Because remember, you can times by something and that won't change the problem. So what I'm going to do is I'm going to times this entire top row by a 4th. Wouldn't that make that a 1 in the place we need? So what I do is to show my work is I go like this. I take row 1, times it by 1/4, which will equal our new row 1. This is kind of how I show my work. And then it really helps keep things nice and like, it really, yeah, because it does. It starts to become like so much. So watch what else I do next. Before I even write in my new row 1, I say the only thing I'm changing is row 1. So I'm not changing row 2, so I write that in real quick. Because people get tempted to change multiple rows on accident. So I write in what I'm not changing, so I'm not tempted to do that. Alright, so now we're going to put in our new row 1. Times by a 4th, and we get a 1, don't we? Times by a 4th, we get 2. Times by a 4th, we get -1. And then times by a 4th, and we get 1. So now check. You have a 1 in the correct position, the X. Now your next step, I'm telling you, always after this, get a 0 below and below. Always get zeros next. Now guys, you cannot times by 0 or else you just cancel out that whole line. So the only way to make this 3 a 0 is to somehow add 2 lines together. Now, as is, that's not going to work. If I add 2 lines together, it's not going to work, correct?
Can you multiply it by its opposite, so like -2 and then -3? So
You could. You're saying like if we multiply by opposites and then add them, that could be 0?
So
Yes.
6's.
Love it. Love it. But an even quicker way, not that that's wrong, that's great.
You can just add 1.
Can I take row 1 and times it by -3? Look, if I take this and have a -3 here and add straight down, won't that make that 0?
Yeah.
So won't that be even easier?
So what change row 1 or no?
No. So, okay, so let me finish here. So we take row 1, we're timesing it by -3, then we're going to add it to row 2, aren't we? To make this 0, everybody? Which will equal our new row 2. Aren't we just trying to change row 2, not row 1? Row 1 we want to stay, don't we? It's good. We can use row 1, but that doesn't mean we have to change it yet.
Once you change row 1, it stays the same. Once you get the 1 each, it doesn't change.
Unless you choose to change it, but we're not choosing to. Yes. Okay, so now let's write out our new matrix. Now, once again, I really recommend saying, see how it says equals row 2? I know I'm changing row 2. I'm not changing row 1 or 3. So I'm going to go put those in so I'm not tempted to change them on accident. You guys see what I'm saying?
Yeah. you kind of do mentally change it to get it to cancel?
Yeah, you have to think about it. So that's a good question. First hour, somebody's like, well, how do you know? There's not a way to know without thinking. How can I, because you thought of a way to manipulate it, you know?
Yeah.
I just thought of a different way. Does that make sense?
You don't, the biggest problem is you don't want your students to basically manipulate the top and keep the top manipulated. You just want to manipulate it so that it manipulates the next line. If that makes sense.
Right. Okay, yes, exactly. Yes.
It's like R2 equals row 1 times negative 3 plus 13.
Yes.
So it's kind of
True.
like just a formula to like
Yeah, good point. It's just a formula to get a nice new row with the 0 where we want it to. Okay, so let's do our work now. So I'm going to go to row 1 and I'm going to just put in parentheses. I'm timesing that by negative 3, even though it's not changing right down here. Does that make sense?
Yeah.
So we're going to times by negative 3, and then we're going to take and we're going to add that to our row 2. Okay, so here we go. 1 times negative 3 is? Negative 3 plus 3 is? 0. Okay, negative 3 times 2 is negative 6. Negative 6 plus 8? 2, right? Guys? Negative 1 times negative 3 is 3. 3 plus 5 is? 8. Negative 3 times 1 is negative 3. Negative 3 minus 11 is negative 14. Awesome. Next step is to get a 0 right here. Now, once we get better at this, we'll be able to sometimes hit 2 birds with 1 stone, which on this one I didn't because we're just starting out.
So for this one, can you manipulate the middle to be 2?
Well, we want this to be a 1.
Oh.
I mean, no, we don't.
0?
Sorry, we want it to be 0.
So could you manipulate the middle to be 2?
No,
Yeah,
good
you
question.
can't multiply
But see, if
that.
we times by 2, then that
That'd
wouldn't
be
help
0,
us,
yeah.
right? But that's a
Yeah.
good point. So shouldn't we use the 1 again? Usually
Yeah.
the 1's helpful when this happens.
So maybe
So
that-
let's take row 1, times it by 2, add it to our row 3, because then look, 2 minus 2 is 0. That will equal our official new row 3. So once again, I personally say, I'm only changing row 3, so I'm going to go right in row 1 and 2, since those aren't changing in this formula. And then I'm going to go ahead and do that. So I'm going to take row 1, times it by 2, distribute, 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 and then I'm adding it to row 3. So then we have 2 times 1, which is 2. 2 plus negative 2 is 0. So cross that out. So then 2 times 2 is 4. 4 plus 1 is 5. 2 times negative 2 is negative 2. Plus 12 is 10. And then 2 times 2 is 2. 2 minus 17 is negative 15. So now you'd say check. I got 1, 0, 0. Now your next step is to go to where your next 1 would be. Which, wouldn't it be right here?
Yeah.
So we need to make that a 1. Now guys, anytime I'm trying to make it a 1, I
Multiply
just
by
times by something. So what would make 2 a 1? So I'm going to say take row 2 times by a half equaling row 2. No, because then that'd be negative 1, wouldn't it? Because we want it to be 1. It's already 2. Yeah. So 1, 2, negative 1, 1. 0 times a half is still 0. 2 times a half is 1. 8 times a half is 4, isn't it? Negative 14 times a half is negative 7. So this is coming out nicely so far. And then we didn't change this one. Now luckily I started out with the longest example, this one, which is good, because then it just goes uphill from downhill. I don't know which one's considered better. Okay, awesome. Now look, what's our next step? What do we need to take care of next?
The 5.
The 5. It needs to be a 0. Okay. Any suggestion? Now, here's the thing, guys. If you choose to do something, I remember this would happen to me all the time back in the day. If you choose to do something, and then it ruins your 1 and 0s, then you're not choosing the right thing, because you don't want to jeopardize the, important things that we've already done. So, but that would make it a 1. We're trying to make it 0.
Did you times by negative 5 row 2? Yeah.
Good. So take row 2, times it by negative 5, because you see how there's a 1, which makes it nice, everyone? And then we're going to add it to row 3, equaling official new row 3. And here we go. So I'm going to write in, once again, what I'm not changing real quick. And here we go. So 2 times negative 5. So negative 5 times 0 is 0. 0 plus 0 is 0. Negative 5 times 1 is negative 5. Negative 5 plus 5 is 0. Negative 5 times 4 is negative 20. Negative 20 plus 10 is negative 10, isn't it? Negative 5 times negative 7 is positive 35, minus 15 is 20. So we got 1, 0, 0, 1, 0. Isn't our last step to get this to be a 1? Yep. We're almost done. Anytime I'm trying to get a 1, I just times by something. Yes. So we're going to take row 3, times it by negative 1/10, which equals our official new row 3. 1, 2, negative 1, 1, 0, 1, 4, negative 7. 0 times negative 1/10 is 0. 0 times negative 10 is 0. Negative 1/10 times 10 is 1. 20 divided by negative 10. Same thing as 10 divided by negative 1/10. Negative 2. So now look what you've gotten it down to. Ones, zeros. Okay, we've got it in our row echelon form. So now we have our true statements, everybody. Our first true statement is z equals x, y, z. Z equals negative 2. So I'm going to circle that because that is an answer we need. Go to your next thing here. We would have y plus 4z equals negative 7. So let's go ahead and solve for y. So we have y plus 4 times negative 2 equals negative 7. Y minus 8 equals negative 7. So y equals, adding 8, 1. We'd add it over, right? And then our true statement on top is x plus 2y minus z equals 1. Plug in what we know. So we have x plus 2 times 1 minus negative 2 equals 1. So look what that becomes. X plus 4 equals 1. So x equals negative 3. So then we write our final answer as our x, y, z point. So our final answer is negative 3, 1, negative 2. Wow. Yay. So yeah, that takes a long time. It does. There's no doubt about it.
But it's just more patience.
Yeah, and it's just, exactly. And I mean, yeah, because I guess some people might think that's easier than solving by the way we solved before. Just depends. Okay, let's do another one. Now, they're not all going to take that long. You're going to see a lot of them just fall in really nice and pretty. Like, you'll see, I'll be able to do this whole problem without scrolling down at all. Like, some of them really will come out so quick. So let's do another one. That was like the longest it could be, basically, that last exam. I wanted to start out with the hardest.
So then we're done.
One, yeah, exactly. Because then you're like, oh, okay. On the next one.
Well, this already is.
Yeah. First step is to write it in its matrix form. Then once again, we start with the 1 right here. Isn't it already good? Now we're even going to get more confident now. We're going to be able to hit 2 birds with 1 stone sometimes. Meaning, all right, the next step is to get a 0 here and here, isn't it?
So can we multiply the top by negative 1?
Yep, so let's take row 1 times it by negative 1, add it to our row 2, which will equal our official new row 2. And at the same time, let's take row 1 at the same time. Shouldn't we times row 1 by negative 1, add it to row 3 as well? Because won't that make those both 0? Which will equal official new row 3. You guys see how I'm just hitting 2 birds with 1 stone? Take that times by negative 1, negative 1 plus 1 is 0, times 0. So I'm just hitting 2 birds with 1 stone. Okay. So now the only thing on this one I'm not changing is the row number 1. It looks like, because I've done 2 birds with 1 stone. So 1, 1, 6, 3. Okay, now let's all focus and not make errors here. So that times negative 1. Wait, I'm going to write that in. So times by negative 1 plus 1 is 0. Negative 1 times 1 is negative 1 plus 1 is 0, isn't it?
Yeah.
Negative 1 times 6 is negative 6. Sorry, I'm going to cross them out. So negative 6 plus 3 is negative 3. Negative 1 times 3 is negative 3. Negative 3 plus 3 is 0. All right, negative 1 times 1 is negative 1 plus 1 is 0. Negative 1 times 1 is negative 1 plus 2 is 1, isn't it? And then negative 1 times 6 is negative 6 plus 4 is negative 2. Negative 1 times 3 is negative 3 plus 7 is 4. Now here's, guys, look, 1, 0, 0 is taken care of. Isn't the next step to get a 1 right there?
Yeah.
There's a 0.
When can you put it?
Yeah, just switch the rows.
Oh my goodness.
So we're just going to now take that up there. Won't that put it in the right spot? Okay, so let's just rewrite. I'm not going to even like write down what I did. I'm just going to switch them real quick. 0, 1, negative 2, 4, 0, 0.
What like would that look like though? Like just the row. If
Well,
you
it'll
put
still
it
be,
in
it's the same system, right? Like, look, if I went back to here, Mason and wanted, couldn't I just switch any of these and it's gonna
Oh.
not change anything? Does that make sense?
Mhm.
Okay, awesome. Okay, now, guys,
You just need 0 then.
now, look, that's not so nice. 1, 0, 0, 1, 0, now we just need a 1.
1. Yeah, so multiply by negative 1/3.
Good. Row 3 times by negative 1/3 equaling our official new row 3. And then we're done. Almost. We're done getting it into row echelon form. 0, 1, negative 2, 4. 0 times negative 1/3, 0. 0 times negative 1/3, 0. 1, 0. Great.
So is our bottom variable z? Is that what you said?
Yes. Well, yeah, because look, x, y, z.
Oh, yeah,
Does
yeah.
that make sense? Okay, so what's my true statement on bottom? Z equals 0, isn't it? Okay, there, I'll go ahead and circle that. Then we have our y minus 2z equals 4. Therefore, let's plug in 0. So that's y minus 0 equals 4. So doesn't y equal 4? And then we have our top true statement, x plus y plus 6z equals 3. Plug in what we know, y is 4 and z is 0.
Negative 4?
So x plus, we're just plugging it directly in, right? X plus 4 plus 0 equals 3. Because 6 times 0.
Oh, yeah, because we have 3 equals, so it would be
Yeah.
1.
Yep, so negative 1. So x equals negative 1, and we're done. So you go negative 1, 4, 0. So we did all that one in even just one slide. So, and once you get better at them, they go pretty quick. So, good job, guys. All right, now the only thing different now is instead of stopping right here at row echelon form, if I so desired, I could keep going. And now that I have 1s on the diagonal and 0s below, if I wanted to solve it completely, instead of by back substitution, I could get 0s here, here, and here, and then I'll have the solutions, right? So that's just what's called, instead of Gauss elimination, it's called Gauss-Jordan elimination. So basically, another mathematician, yeah, that's what I joked about last hour. I'm like, so another mathematician got involved, Jordan, first or last name, one of the two, and they worked together, and like, so Gauss got it to the row echelon form, and then Jordan realized, well, we can also get 0s above, and that'll be our full solution set. So basically, when you see the Jordan, think of home run, even though I know he didn't play baseball, he played basketball, but like, take it all the way home, simplify it all the way, like, so yeah. Oh, he did play, okay. He just wasn't famous for it, okay, gotcha. So basically, guys, once again, if you were ever asked to solve with Gauss-Jordan, when you say, just when you see the word Jordan, say, oh, that's the one where I have to go all the way. All right, so the only difference is instead of stopping right here and doing back substitution, after that we'll then get a 0 here, here, then here. Now, the order does need to stay the same, guys. You're going to want to do the same steps, 1, 0, 0, 1, 0, 1, and then you're just going to go backwards. So 1, 0, 0, and we'll already have our 1, and then 0. So you're going to get it in that order. So get your 1, 0, 0s, you know what I mean? Go in order, 1 down, 1 down, 1 down, basically, and then back up.
Oh, so just think of it as like
It's just backwards.
right angles, but like in opposites.
Yeah. And then once you have it in Gauss-Jordan elimination form, then it's reduced row echelon form, we're done, we're solved. So let me just show you. We already solved this one, but instead of solving it by Gauss elimination, we're going to go Gauss-Jordan elimination. So basically, guys, we already have done this one. We took this, we wrote it in its matrix form. We did math, and we got it to this form right here. Now, normally, when we got it to this form right here, we did back substitution. If we are now going to go Jordan, we got to keep going. So you do start out the same, okay? Now watch. So I would maybe on my notes write down at this point how to keep going. So the next step is once you have your 1, 0, 0, 1, 0, 1, you would get a 0 here and here. Just like we have, you know how 1, 0, 0? Same thing. So what could we do? Now make sure, whatever you do not jeopardize changing the 1s and the 0s here. So won't we take row 3, times it by negative 4,
Yeah.
add it to row 2, equaling new row 2. Because look, 0s are nice, because then when you times, it won't change when you add them. Does that make sense? Yes? Yeah, that'll have to be 0. But once again, I just suggest going in this order. Not that it's wrong if you don't. It's just it kind of gets all.
So should we write our top row the same right now?
Well, we're not. What? So once again, it's the same thought process. We're only changing row 2, aren't we?
So just write
So I just I do that same thing all the way through. I say, okay, I'm only changing row 2. So 1, 2, negative 1, 1, and I'm not changing row 3 either, even though I'm using row 3. 0, 0, 1, negative 2. All right, so now let's go ahead. Go to row 3, times it by negative 4. So 0 times negative 4 is 0. 0 plus 0 is 0. Negative 4 times 0 is 0. 0 plus 1 is still 1, isn't it? Negative 4 times 1 is negative 4. Negative 4 plus 4 is 0. And then negative 4 times negative 2 is positive 8. Positive 8 minus 7 is 1. Okay, now we need to get a 0 here. Row what? With what? Yep, so row 3 plus row 1, which will equal our new row 1. So we are changing row 1, so I'm going to write in row 2 and 3 real quick. 0 plus 1 is 1. 0 plus 2 is still 2, isn't it? 1 plus negative 1 is 0. And then negative 2 plus 1 is negative 1. And we have one last step. Because look, you have your 1s and your 0s. You just got to get a 0 right here.
So did you just add those?
Yeah, you can just add the row 2. Yep, good. So we need to take row 2, times it by negative 2, add it to row 1. You guys see why they're choosing that? Because there's a 1 here. That's really the only way to fix it. And then, which will equal our new row 1. And then we're going to have solved it completely. So then we have our, so let me hurry and write in 0, 1, 0, 1, 0, 0, 1, negative 2. And then the top row became, so timesing this by negative 2. So 0 times negative 2 is 0. 0 plus 1 is 1. Negative 2 times 1 is negative 2 plus 2 is 0, isn't it? Negative 2 times 0, 0, 0 plus 0 is 0. And then negative 2 times 1 is negative 2. Negative 2 plus negative 1 is negative 3. See, it's getting sloppy. Now look, x, y, z. Isn't those your answers? So we have x equals negative 3, y equals 1, and then z equals negative 2. Which we already knew. Yeah, it's just, exactly. It's just more thinking, exactly. That's why, if I have the choice, I usually just stop at the back substitution part.
Would it ever, like on a test or something, would it ever say
Yes, it could. Yeah, it could. So I would just make sure, like, on the one where it says choose, I'd pick a few and just make sure, like, say I'm going to just do it. Okay. Okay, awesome. Let's do one from start to end with Gauss-Jordan elimination. Do you agree? That might be a good idea?
There's more after this?
No, the only thing we have to talk about is when we have no solution and infinite solutions, which is quick. So actually, this is really our last big example. So how are we doing on time? We get out at 11:22, so we're still doing really good. Okay, awesome. We might even have some class time. Okay, first step. Everyone stay focused with me. First step is to get your 1 right here, which is good. Now we need to get a 0 here and here. Let's hit 2 birds with 1 stone. Row 1 plus row 2 equaling official new row 2. Then we're going to take row 1, times it by 2, add it to row 3, equaling new row 3. Uh-oh. Yep, it's going to times by negative 2. Good catch. No, you don't need to hit 2 birds with 1 stone. So 1, 1, 1, 4. Okay, let's focus on this second one. So we're doing row 1 plus row 2. That plus that is 0. That plus that is 3. That plus that is 4. And then 7, 21, right? Okay. Row 1 times negative 2. and then add it to our row 3. So negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times negative 2 plus negative 1,
Alright, oh yeah, yeah.
right? Oh, sorry. Let me cross them out so we can stay on track. So won't that be negative 3? And then negative 2 times 1 is negative 2 plus 0 is negative 2. Negative 2 times 4 is negative 8. Negative 8 minus 7 is negative 15. Okay, 1, 0, 0. Check. Next step is to make this a 1, right? Don't we want this to be a 1? Yeah. So we're going to take row 2, times it by a third, equaling new row 2. Now notice that is going to make us deal with a fraction, but there's sometimes just no choice, and it really does. A lot of times the fraction ends up canceling out in the end. So 1, 1, 1, 4 is not changing. We're only changing row 2, so 0, negative 3, negative 2, negative 15. Okay, here we go. Take row 2 and times it by a third. Times by a third is still 0, isn't it? Times by a third is 1, so then 4 thirds, won't it be? And then a third, that's the same thing as dividing by 3, which is 7. We didn't mess up, right? It wasn't negative or something. No, I just thought I remember it being negative. Okay, cool. Now look what we got. 1, 0, 0, 1. Don't we need to make this 0?
Yeah, so then maybe multiply the row 2 by positive 3?
Yes.
Maybe do row 1
Oh,
But careful, because you don't want to undo these zeros, guys. So that's a good point. I'm glad you said that. Look, if I choose row 1 and then add it down, won't that change this 0? Yes, guys, it would. You would change your zeros and stuff. That'd be bad. Yeah. Row 2 and row.
like on that purple one.
Yeah, but that'd be 0, right?
So like
You can't go back though. If you would have chosen to do that from the get-go.
yeah, like if you chose to do that first.
Yeah, but once again, yes, it's not wrong if you do that, but once again, I recommend sticking with the pattern I've given you. So that's getting off track. Does that make sense a little bit? You're choosing to get a 0 and then... Not that you'd be wrong, necessarily. You wouldn't be. But I'm just saying, if you stick to the plan, it usually works out. Guys, it really isn't that bad. Let's just go with it. Let's just go with it. Not that that's wrong, because we did that second hour. They wanted to, I'm like, fine, we can do it, and it ended up being fine. But I'm just saying, sticking with what I'm giving you, the suggestion, it usually helps. Okay, take row 2. We're trying to get this to be a 0, guys. So take row 2 and times it by 3, add it to row 3, equaling new row 3.
So we keep row 1 and 2 the same.
Yep, so let's keep row 1 and 2 the same. Not that, once again, I can't stress enough that it's not wrong if you were to choose to get that 0. It's just,
Would be more work.
no, it might be a little, it might be less work, but then you're kind of going about it randomly and then proceed with caution. Good luck to you.
It's just more risky.
It's just risky. It gets really messy. So we still have this stuff. Okay, so now here we go. Look, it's actually going to come out nice and pretty. If we times all this stuff by 3, isn't that what we're doing? So look, 3 times 0 is 0. 0 plus 0 is still 0. 3 times 1 is 3. 3 minus 3 is 0. Then look, 3 times 4 thirds, the 3's cancel out. That's just 4. 4 minus 2, 2. And then that would be 3 times 7 is 21, minus 15 is 6. Okay, now your next step is to get a 1 right here. So take row 3, times it by a half, which equals new row 3. Why are people laughing? Did I do something? Okay. I didn't know if there was like something hanging off my butt or like, okay. Do you guys see why I'm doing what I just did? But I'm the one like stating it and I'm recording. Okay, so then 1, 1, 1, 4, 0, 1, 4 thirds. Still not pretty, but it's gonna, you'll see it, it's not bad. Oh, we're changing this, okay. So we're taking row 3 and times it by a half. A half, still 0, isn't it? Times by a half. 1 times by a half. 3. Okay, good. Now, next step, right, we're trying to get reduced row echelon form, aren't we?
Yeah.
So now the next step is to get a 0 right here.
Yeah.
So take row 3, times it by negative 4/3 and add it to row 2 equaling new row 2. Okay, so then we have 1, 1, 1, 4, 0, 0, 1, 3. Okay, let's do that.
I'm doing row 2 right now. Okay.
So we're timesing this by negative 4/3. Okay, so look, 0 times negative 4/3 is just 0. 0 plus 0 is 0. Negative 4/3 times... No, because we're adding, right? You're okay. No, I've had a few people actually, you're not the only one today say that. 0 times negative 4/3 is 0. 0 plus 1 is still 1. You can see how we haven't jeopardized anything here? And then, right, 1 times negative 4/3 plus 4/3 is 0. We're golden here. And then look, this is where finally our fractions cancel out. Isn't that just negative 4? Which is negative 4, isn't it? Negative 4 plus 7. Look, 3 on top, 3 on bottom, guys. Negative 4 plus 7. And now we no longer even have fractions. Okay, we're almost there. We need a 0 there and there, but let's stay in order. We need a 0 right there. So when I take row 3, times it by negative 1, add it to row 1, equaling new row 1. Okay, so I'm going to write in row 2 and 3 real quick. So we're going to take this, times it by negative 1, and then add it to row 1. 0 times negative 1 is still 0. 0 plus 1 is still 1. Negative 1 times 0 is 0. 0 plus 1 is 1. Negative 1 times another 1, 1, and then 1 plus 1 is 0. Negative 1 times 3 is negative 3, plus 4 is 1. And then our last step is to make a 0 right there. Times by a half. Where are you timesing by a half? Okay. No, you're fine. These are valid questions. Okay, now why are we trying to get the 0 here, guys? Yep, so take row 2, times by negative 1, add it to row 1, equaling new row 1, and then we are, hallelujah, done. So we would have 0, 1, 0, 3, middle row is the same, bottom row is the same. We are changing our row 1, so we're going to take row 2, and we're going to times it by negative 1. Negative 1 times 0 is 0. 0 plus 1 is still 1. Negative 1 times 1 is negative 1. Plus 1 is 0. Negative 1 times 0 is 0. 0 plus 0 is 0. Negative 1 times 3 is negative 3. Negative 3 plus 1 is negative 2, isn't it? And boom, there's your answers. X equals negative 2. Y equals 3. Z equals 3. Woo! Okay, awesome. You guys can do it, I promise, okay? Now here is the last little piece. What happens when we get, remember, we're just solving a system of equations, which means there can be no solution and there can be infinite solutions. So let's talk about that. So there are the 3 types of solutions we're going to see. Now look what happens, guys. If you are solving it, you're just going about, you're not going to know it has no solution. You're going to be going about solving it, and what's going to happen is the math is going to lead you to this point where on the bottom, 0, 0, 0, 1. Do you see how all the variables canceled out? Because 0x plus 0y plus 0 is equals 1. Well, isn't 0 times anything just 0? 0 equals 1, which is not a true statement. All the variables canceled out because they have all zeros. So then there's no solution because it's not a true statement. Just like when we did it by elimination and substitution. Now we just saw when we have one solution what happens. We'd get to where the variables don't cancel out. So we'll have a specific z, then we'll back substitute. Now what happens when we have infinite solutions, guys, is you're going to have a point where all of the variables cancel out, and it is a true statement. Because look, variable canceled out, and it equals 0. So 0 equals 0 is a true statement. Now, guess what? There's I've never seen so many people besides this class write on the test we just took no infinite solutions. That's not the answer. The answer is that infinite solution. You can't just write infinite solutions. That's not an appropriate answer. Yeah, it's infinite solutions that fall on the plane. Or fall on the line. You know what I mean? So just a reminder, how do we write that? So let me go back. You'd say, I know that there are infinite solutions. So what true statements do I have? Well, look right here. Isn't this 1y minus 1z equals negative 2? I got that. I wrote it down here. Then right here, don't I have 1x plus 2y minus 3z equals 1? So I have these true statements. You've got to choose a variable to remain the variable, and then after that, write the other two variables in terms of the variable you chose. So I said, in XYZ, I'm going to choose Z to be Z. So look at my final answer. I put Z as Z. Now Y needs to be an equation of Z. So look, get Y alone. So I added Z. So Y is equal to Z minus 2. Do you guys see why I wrote Z minus 2 right there? And all I have to do is go back up here. Now look what you have. I'd say I'm going to solve for X. So X is equal to, I'm going to subtract 2Y to this side and add 3Z. So I have negative 2Y minus 2Y, add 3Z. Don't I still have a plus 1? But now I can only have Z's in my equation. So I'm going to go X is equal to negative 2. Y isn't Y. Isn't Y Z minus 2? Plus 3Z plus 1. So I would distribute, combine like terms, and you end up with Z plus 5. So Z plus 5, Z minus 2, and Z. And then remember, the book will usually go T plus 5, T minus 2, T. They'll just change up the variable. So it's like, I'm not being specific to give it to Z. Yes, if you pick Z.
Yeah.
Yes. Awesome. All right, so let's just do I don't think you would need to write down these examples. I'm going to show you one with no solution, one with infinite solutions, and they'll go quick. Do you guys want to see one of each? They'll fly, because you'll see. So everybody just, I don't think you need to take notes during this part. I think watching you'll get more out of it. 1, negative 3, 2, well. Okay, here we go. Let's try to hit as many 2 birds with 1 stone as we can. We need there to be a 1 right here, check, correct? Now we need 0, 0, 0, so I'm going to take row 1 times by negative 2, add to row 2 equaling new row 2. Somebody start doing the math there. Then I'm going to take row 1 times it by negative 1, add it to row 3 equaling new row 3. Other people start doing the math there as I'm writing down the new matrix. I'm not changing row 1. So if you get, say, I've got row 2 as, think. I've got row 3 as, how about this bottom one? Anyone else get it? We can just go quick. 0. Oh my heavens, it's faster for me to freaking do it. Negative 1 times 3 is 3. 3 plus 2. 3 plus negative 2.
Plus 1.
1. Oh my heavens. Negative 2 plus 3. 1. Negative 12 plus 20. 8. Okay, now we get a 1 here, check. Next step is to get a 0 here. So I'm going to take row 2 times by negative 1, add to row 3, equaling new row 3. So 1, negative 3, 2, 12, 0, 1, 1, negative 10. Okay, here we go. 0 times negative 1 plus 0, 0. That plus that, 0. 0 again, don't we get? And then we have negative 1 times negative 10, which is 10. 10 plus 8 is 18. And now do you guys, when you ever see 0, 0, 0, you're like canceled out. 0 equals 18 is not a true statement, so no solution, so I'm done with the problem. Moving on to the next one. Okay, last example of the day is an infinite solution one. And maybe you don't feel the need to see one with infinite solutions. What do you guys think?
I say try it.
Okay, we'll go quick. I mean, we'll go quick if you'll help. You guys owe me that after you know what, the incident we don't speak of.
What incident?
The one we don't speak of, especially on camera. Okay. Hey, now, what should I do?
That took me 10 seconds.
Get this to be a 1, but there's a, what should I do? Just switch?
Yeah, sure.
Yeah, you just
Oh, good catch. I'm glad someone's paying attention. Okay, so you're saying we should just switch these. Okay, I I agree. So let's hurry and do that. So 1, 1, negative 10, negative 4, then negative 1, 0, 7, 5, negative 3, negative 5, 36, 10. Okay, next step is to get a 0 here and here. So won't I do row 1 plus row 2 equaling new row 2? And then let's do two words. Row 1 times 3 plus row 3 equaling new row 3. All right, you guys start doing it while I write down the like row 1.
It's going to go 1, 1, negative 10, negative 4, and then it's going to go 0, 1.
Right here, 1.
Yep. 3, negative 3,
Okay.
and then 1.
Okay. Six? Yeah, I know. 2 or negative 2? 2. Okay?
Wait.
Freaking A. Okay, that's okay. Negative 2. I'm like, okay, here I am, like, asking you to help, and then when you don't get it right, I'm like, you idiot! I'm like, okay, calm down, that's no wonder no one wants to help. Okay, I'm okay that you got it wrong. I'm sorry. Okay. Alright. So, next thing 1, 0 here. So we're going to take row 2 times by 2 equaling new row, row 2 times 2 plus row 3, right? Plus row 3 equaling new row 3. Times that, isn't it 0 again? Woo! And then we get 0, do we get 0 again? Okay, look, true statement, 0 equals 0. So now don't say infinite solutions, everybody watch. I'd say, so x, y, z, and then I would say, okay, I'm going to make one of the variables be one of the variables.
Let's do y.
So let's write out actually our true statement first. So right here we have y minus 3z equals 1. Wouldn't it be easier to just get y alone? So y is equal to? So wouldn't it be easier to leave z as z? So I'm going to go to my final solution set, say leave z as z. Y is 3z plus 1. And then x, let's go back to here. We have x plus y minus 10, z equals negative 4. So then we would have x is equal to, I'm going to subtract y, everybody, and add 10z, and then I still have minus 4. But now y isn't y, right? Now I'd make sure I distribute the negative, so I have x is equal to negative 3z minus 1 plus 10z minus 4. So won't that be 7z minus 5?
Yeah.
7z minus 5. Okay, that's the end of the lesson. Start practicing. So you guys will have a hot date tonight with Gauss Jordan.